in question 1, we can express this number in partial fractions as a all over x minus 1 plus b all that over x plus 2. So this is identical to this number that has been given here. And when we multiply all through by the denominator, we will be left with 5 plus 1, that is 5x plus 1, to be identical to a into x plus 2 plus b into x minus 1. Now this step, when x is equal to 1, what are we going to have? To imply that when you put 1 into 5, you will have 5 times 1, 5, so we'll have 6 to be equal to 3a, and in this case, a will be equal to 2. Now, when x is equal to minus 2, we will have minus 2 times 5, that's minus 10 plus 1, minus 11. Minus 9 should be equal to minus 3b's. And in this case, b equals 3. So a is 2 and b is equal to 3. And when we put this into what we already have here, we will have a, we already have a to be equal to 2. So 2 over x minus 1 plus 3 over x plus 2. So the key here is C. Question 2, the equations of the vertical asymptotes. So that function is given by, so when you have a rational function, that is a fraction in which there are variables in the denominator, to get the equation of the vertical asymptote, equate that denominator to 0 and solve for x. So x equals plus or minus 1 when you solve. So the two asymptotes are x equals minus 1, x equals plus 1. So these are the two vertical asymptotes to this curve, and the key is C. Question 3, the two functions f and g are defined as f equals that and g equals that. We should find the composite function g of f. So the composite function g of x just means in the function g, replace x by f of x. So g of f of x will be equal to f of x minus 2. And this is giving us f of x is 2x plus 3. So finally we have 2x plus 1. And the key here is A. Question 4, you are given that matrix, then the cofactor of the element 6 is, when you look at the position 6, it is at the second row and third column. So I is equal to 2 and j is equal to 3. And how do we get the cofactor? So the cofactor is given by, we have minus 1 to the power I plus j, and at the position 6, we will have 1, 2, 7, 8. But our I here is equal to 2, that is root 2, and our j is equal to 3, that is column 3. So this is giving us minus 1 to the power 5. And minus 1 to the power 5 is equal to minus 1 times all of this. So our cofactor is the one with the negative. So it will be negative 1, 2, 7, 8. So our key here is A. Question 5, we have that equation in index form or exponential, and we have to look for the value of x. Note that to look for the value of x, since x exists here as a power, we must make the basis the same. So I will have my, instead of writing 4 as common base, I'll have 2 to the power 2. All of this raised to the power 2 minus x should be equal to 2 to the power 2 times 2 to the power 1 minus x. And from the law of exponents, this will give me 2 to the power 2 times 2, 4 minus 2x to be equal to 2 to the power 2 minus 2x. 2 minus 2 minus, So in this case here, since I'm multiplying these indices, I add the power. So 2 plus 1 minus x. So finally, we are going to have an equation of the form 2 to the power 4 minus 2x is equal to 2 to the power 3 minus x. And from here, we will have 1 to be equal to x, or x is equal to 1. Question 6. Question 6, given lindat equals lindat, find the value of x. So using the laws of log, ln x plus 6 times plus ln 9 can be written as ln 9 times all of this x plus 6. And this should be equal to the other on the right hand side, ln x plus 7 times 6. So we can use this brackets like this. But now, since we have ln on both sides, so we can just equate these values. So we have 9 into x plus 6, that is 9x plus 54 should be equal to 6x plus 42. So this gives us 3x to be equal to 3x to be equal to negative 12, and x to be equal to minus 4. So x is equal to minus 4. Question 7. The roots of the quadratic equation are real, then what do we have? So for us to have real roots in quadratic equations, as you already know from lower seat work, the determinants, the discriminants rather, delta, that is b squared minus 4ac, should be greater than or equal to 0. So let's look for a discriminant here. In this case, we'll be having b is minus q squared minus 4 times a is p, times c is minus r. All of this should be greater than or equal to 0. So this gives us q squared minus, now plus 4pr to be greater than or equal to 0. So this is what we have, and the key there is B. Question 8, to find the limit that is presented there. Well, I would like us to solve using a shortcut. We know very well that the limits as x tends to infinity of 1 plus 1 over n, I'm quoting, is equal to e. Therefore means you can use this as a shortcut to get this other limit. Now, as a shortcut, Now that we have the limits as x tends to infinity of 1 plus 2 over 3, all of that, n. That's 2 over 3n, which can be written as this. We can equally quote. Normally, this number here at this position will affect our answer. I'm giving shortcuts, e to the power 2 or 3. In fact, the number at this position should be used as the power here. But how do we do this? To further explain, so that people don't ask, but how did the answer come about? So this is what we are going to do. You write this as this limit to be equal to the limit as n tends to infinity of 1 plus 1 over 3 over 2n, or this to the power n. Normally I can bring out these 2/3, I can bring out this number, and this one can be written as the limit at infinity of 1 can be written as the limit 1 plus 1 over n to the power 2 over 3m, where my n, in this case now my n is equal to 3 over 2m. So this limit now becomes the limit at infinity of 1 plus 1 over m, all this to the power m raised to the power 2 or 3. Raised to the power 2 or 3. And this will be equal to e to the power 2 or 3. So this limit here is equal to b. Question 9. We are given the two statements P and Q. The converse of P implies Q is. Converse just means you should reverse the arrow. Yeah, so if P implies Q, then Q now implies P. So the converse of this statement now is Q implies P. That's the converse, B. Question 10, the solution of the simultaneous equation that. So when we solve this simultaneous equation, I'll maintain equation 1. And equation 2, I want to eliminate y and multiply all through by 3. So 9x minus 3y is equal to 21. And when we subtract, no, not subtracting, rather, add, we will have 11x to be equal to 22. And from here, x will be equal to 2. And when we substitute this value of x in the equation, we will have our y to be equal to minus 1. So we have D. Question 11. To find the limit of that function. So when you look for the limit as x tends to 0, because 0 is 1. So 1 minus 1 is 0. 0 divided by 0 is undefined. So we have to use the hospital rule, as you guys call it, L'Hopital's. So we differentiate the numerator. When we differentiate minus cos x, we will have, so 1 minus cos x, when it's differentiated, we will have so this limit now as x tends to 0 will just be equal to sine 0, which is 0. So that gives us A. Question 12, we are asked to use the substitution u equals 1 plus x squared to find that integral. So for this integral, my du will be equal to 2x dx. And when I bring it into this my integral, I will have, and now note when I'm using this now, the limits will change. So at x, u. So when x is equal to 0 from that limit, 0, I'll have 0 squared is 0 plus 1, 1. And then when x is equal to 1, 1 squared is 1 plus 1, 2. So I'm going to change it in this limit. So I'm now integrating from 1 to 2, from 1 to 2, and my 2x dx is u. So I have u to the power 3 du. This integral will give me u to the power 4, all this on 4, from 1 to 2. And from 1 to 2, I will have, by subtracting, 2 to the power 4 is 8. 2 to the power 4 gives us 8. Minus 1 to the power 4. 1 to the power 4 gives us 1. All that on 4. 2 to the power 4, 16. So this will give us finally 15 on 4. 15 on 4, which is A. Alright, so 2 to the power 4 gives us 16. Now 16 minus 1 gives us 15. 15 on 4. Question 13, we have to look for that integral as well. When you look at this function in this integral, we find out that the degree of the numerator is equal to the degree of the denominator. So we first of all have to express it in partial fractions. And this will give us 2x over 2x plus 1 over 2x. So this one will cancel out. And our integral will be the integral of 1 plus 1 over 2x dx. So this will give us x plus a half ln x plus a constant. X plus half ln x plus a constant. So our key here is a. The key here is a. Question 14, using the Moivre's theorem, the complex number cos theta plus I sin theta to the power 5 equals. So from the Moivre's theorem, R, which is the modulus or magnitude, is equal to 1. So this complex number can just be written as cos 5 theta plus I sin 5 theta. So we have cos 5 theta plus I sin 5 theta. And this gives us C as the key. Question 15. Given that U and V are coplanar vectors, that is vectors that lie on the same plane, where U is that and V is equal to that, find the cross product U cross V. So U cross V, I have my I, J, K. My U is a vector 2 minus 1, 6, 2 minus 1, 6. And my V is minus 3, 5, 1. Minus 3, 5, 1. So when I get this, I'll have for the I component, I will have minus 1 times 6. Minus 1 times 6 here. Minus 1 times 6. That is minus 1 times 1 rather. That is -1. Minus 5 times 6. So minus 30. plus my j component I have minus, that's now minus j into 2 times 1, which is 2, minus 3 times 6 minus 18, so plus 18 plus 18, and then plus k 2 times 5 10, minus 1 times minus 3, so 10 minus 3. So when we simplify all of this, we are going to have minus 31i minus 20j's plus 7k's minus 31i's minus 20j's plus 7k's. So our key here is A. Key here is A. Okay, the next question, question 16. The function f is continuous on that interval and differentiable on that interval. Using the mean value theorem, there exists a value c such that, so the mean value theorem, what's called intermediate value theorem, makes it clear. So f prime of c should be equal to like a gradient, f of b minus f of a, all that on b minus a. So this gives us b as the key. Question 17. Question 17. The tangent of the acute angle between the lines that and that is. So to get the tangent of the acute angle, so let's say for example, this is an xy plane. This is the first line, this is the other line, L1 and L2. This is the angle theta that we are looking for. From here to here is angle A, and this one is angle B. So from here, our theta is equal to B minus A. And what will be tan theta? Tan theta will be equal to tan B minus A. And how do we simplify tan B minus A? Tan B minus A is equal to tan B minus tan A, all this on 1 plus tan B tan A. Where these are tan B, you can call it M1, and tan A, M2. So you can equally be written as tan theta is equal to M1 minus M2 over 1 plus M1, M2. Well, normally you can put this sign as well. So, but from these two lines that we have, we see that for the first one, M1 is equal to 4, and M2 is equal to 1. Those are the gradients. So this will give us 4 minus 1 over 1 plus 4 times 1. This will give us 4 over 3 as a tangent. So the key is, you see, our key is 4 over 3 over 5 rather. So it's 3 over 5, sorry. 4 minus 1, 3 on 5. So our key is C. Key C. Question number 18, the general solution of the differential equation, that is, so this differential equation, we start as a direct differential equation. So in this case, our y, divide both sides by 1/3, our y will be equal to 1/3. When you integrate 1/x², we have as x to the power minus 1 on minus 1. So we have minus 1 on x. And when we integrate x, we have x² on 2. So this can be simplified and written as 1/3 into x² on 2 minus 1/x. And this gives us the answer, or the correct key, to be A. The key is A. Question 19. The geometric progression has first term 16 and sum to infinity 40. The common ratio of this progression is, note that the sum to infinity of a GP is given by S infinity is equal to A over 1 minus R. Note that the R should lie between minus 1 and plus 1. Otherwise, the sum to infinity, if it's greater than 1, the sum to infinity will just be equal to infinity. So applying this, we will have sum to infinity 40 to be equal to the first term 16 over 1 minus R. So this gives us so this will give us 40 into 1 minus R to be equal to 16. And when you open out the brackets, we will have you have 40 minus 40R to be equal to 16. So 40 minus 16 is giving us 24. It's equal to 40R. And R will be equal to 24 on 40. So we have 8 here 3 times, 8 here 5 times. And this gives us 3 on 5. B. Alright, question 20. The equation of a line is that, and the equation of a plane is that. The sine of the acute angle between the line and the plane is. So if you have a plane AX plus BY plus CZ plus D equals 0, and we have a line with parameters M, N, L, this for the line, then you can look for the sine of the angle, the acute angle between the line and the plane, as follows. Sine theta will be equal to, we substitute the parameters of this line into this plane. So our X, Y, and Z will become M, N, and L. So we have AM plus BN plus CL. It should be positive. All this on the square root of A squared plus B squared plus C squared times the square root of M squared plus N squared plus L squared. So this is how we get the sine of that acute angle. So putting all of this in, or replacing the values that we have in this formula, we will have 1 into 3 plus 3 into 1 minus 2 into 2 absolute value. All this on 1 squared plus 3 squared plus minus 2 squared square root, the square root of 3 squared plus 1 squared plus 2 squared. So this will give us, for the numerator we have 2, the denominator we have root 14. So this will be equal to 2 over 14, which is equal to 1 over 7. Yes, because you know that root 14 times root 14 is equal to 14. So this gives us C to be the key. Question 21. Well, I'm sorry that we are doing it slow. Students complain that our other videos are very fast, so we had to go down a bit. Just to draw your attention that there are many other videos which are available, and you can visit our blog to have much more material and even some preparation material for the VC. Question 21. The solution set of that inequality is, notice that for this inequality, you have to first of all bring everything to the left-hand side. So I will have my x plus 1 on x minus 2 to be greater than or equal to 0. So in this case now, this will give us the LCM is x, so x plus 1 minus 2x, all this on x, it should be greater than or equal to 0. So finally I will have x, that is minus x plus 1, all this over x to be greater than or equal to 0. And from here, our boundary solution, our boundaries, you have x equals 1 and x equals 0. Those are the boundaries. So this can now be 1 minus x over x greater than or equal to 0. Can you use my number line now to go fast? This is 0 and this is 1. So I want to test and see the relation that satisfies. So any number less than 0, for example, minus 1, put minus 1 here. 1 minus minus 1, that is 2, all over minus 1. This gives us a negative number. This region is negative. Between 0 and 1, you can take a half. 1 minus a half is positive, and over positive to this region is positive. And any number greater than 1, for example, 2, 1 minus 2 is negative, 1 over that, so this region is negative. But this inequality wants this value to be strictly greater than, to be greater than or equal to 0. So only this positive region satisfies. Therefore means that my solution should be x greater than or equal to 0, less than or equal to 1. All right. When you look at the results that are in question 21, you find out that the key is actually not there. The key is actually not there. And well, since you must tick something, since there is no penalty for ticking any other alternative, so in this case, it should just be advisable if you can tick C. Yeah, advisable. Question 22, given that 4 cos theta plus 3 sin theta is identical to that, the values of R and tan alpha are respectively. Normally you can do this by shortcut, but let's just do it the normal way. So normally R should be equal to 3 squared plus 4 squared, square root of that, and that gives us 5. That gives us 5. Now we are left with tan theta. So for the tan, or tan alpha rather, which one do we use? So for our tan, we use by the value that is in front of cos. The value that is in front of cos is 4, over the value that is in front of sine is 3. Note, I am not using sine on cos. I'm using the opposite. The value in front of cos over the value in front of tan, instead of, because if I divide directly, it's not making sense. It's a shortcut rather. Anyway, you know, we can still expand and we have the same result. So you can do it, you can expand and you have the same result, but it's just a shortcut. So our key here will be D. Anyway, let me expand and then we see what happens. So in this case, when you expand the right hand side, we have r sine theta cos alpha plus r sine alpha cos theta. Now, when you compare these coefficients with what you have on the equation, we will see that r sine alpha is equal to 4 and r cos alpha is equal to 3. So from here now, when we divide this by what you have the other way, r cos alpha, you see what you have, right? 3. So it's giving us tan alpha cos 4 on 3. So the key is D, as we just mentioned. Question 23. A circle with radius 4 has its center at 2, 4. The equation of the circle is x minus center value, that's 2 all squared, plus y minus center value, that's 4 all squared, should be equal to the square of the radius. 4 times 4 is 16. So this is the equation of the circle, and the key here is A. Question 24. The general solution of that is, so we know that cos inverse of, there's a cos inverse of root 3 on 2 is equal to pi on 3, or 60 degrees, as call it, but know that the values are usually given here in terms of pi. So the general solution for cos, knowing that cos is an even function, will be theta equals 2n pi plus or minus that value that we have, pi on 3, where n is an element of the set of Z. So this gives us the key to be A. So the key is A. Question 25. Given x and y are two variables related by the equation y equals ax squared plus bx, where a and b are constants, a suitable linear transformation for this non-linear equation is, when you look at all of these equations, even if you don't solve, you see that C and D are frightful and really do not make sense. Why do C and D not make sense? Because I have x appearing 2 times on the right hand side. It really does not make much sense. Yeah. Because we would like this equation to be in the form y equals mx plus c, a suitable linear scale. But the scales in C and D do not really look linear. And the scale in B, x appearing twice, it does not also make sense. So the best scale here, though B may be tempting, the best scale here is a scale dividing all through by x. You have y over x to be equal to ax plus b. So this is a suitable linear scale, where this now is in the form y equals mx plus c. So this gives us A as a key here. Question 26. A partial order relation is that which is. So a partial order relation is just like an equivalent relation, except for one rule, except for the second rule for an equivalent relation. So instead of being symmetric, it should be anti-symmetric. So equivalent relation is a relation that is reflective, anti-symmetric, and transitive. Reflexive, anti-symmetric, and transitive. Question 27. Given the parametric equations x equals that and y equals that, where theta is the parameter, find the y to x. Find the y to x. So the x, the theta, okay, the x over the theta is equal to 2 plus 2 cos 2 theta. dy over d theta is equal to, when you differentiate this one, you are going to have minus into minus 2 sine 2 theta. This one now becomes a plus. So our dy dx will be equal to dy d theta divided by dx d theta. So this will just give us 2 sine 2 theta, all this on 2 plus 2 cos 2 theta. But since the 2 is common, I can factor out the 2 and I'll cancel out to have these 2 will disappear. This will give us sine 2 theta, all this over 1 plus cos 2 theta. 1 plus cos 2 theta. It's very important that you solve along as I am solving, because the speed is really slow and we can be working at the same time. And the explanations take more time because I have to explain what I am doing, so it takes more time. If I was actually solving, we will go faster. Make sure you don't just watch, solve along. All right, the key here is D, question 28. Question 28, we are given that expansion 1 plus ax to the power half equal to that to find the values of a and b. So we can expand. When we expand what we have on this left-hand side, normally we will have 1 plus a half into ax. Normal this on 1 factorial, this one is on 0 factorial, plus a half into a half minus 1 minus a half, then this one now squared. All these are how many factorials now? 2 factorial. So actually, when we simplify this, we will have 1 plus 2ax, that's the half ax, sorry, plus the half times minus the half is minus 1 quarter divided by 2 is minus 1 over 8. So here minus 1 over 8. A squared x squared. A squared x squared. So let me write it out back. So we have 1 plus a half ax plus, or rather minus 1 over 8 a squared x squared. And when we compare what we have on the right hand side, we'll see that this term like this is equivalent to x over 2. So from here we see that our ax, cancel out this x, you'll be left with half a to be equal to a half. So a is equal to 1. A is equal to 1. And we have bx squared, all of this one like is equal to bx squared. Bx squared. So we cancel out this x squared. We'll be left with b to be equal to minus 1 over 8 a squared, but a is 1, so b should be equal to minus 1 over 8. B is actually equal to minus 1 over 8. So our key in this particular question number 28, we have, looking at the variable, you have B as a key. All right, question number 29. The number of arrangements of the letters in that word is actually given by, number of arrangements of the letters in that word is given by. Now when we look at this word assassination, you see that the there are 13 of them. So we have 13 factorial ways of arranging. But how many A's are equally there? We have 3 A's. So 3 divided by 3 factorial, that's for the A's. Then for the S, we have 4S. 4 factorial, that is for the S. Then how many I's are there? 2 I's. 2 I's for the I's. And you equally have 2 N's. 2 factorial for the N's. So actually, this is the number of ways of arranging the letters in the word assassination. And our key here is B. B. Question 30, the sum of the first n terms of a sequence is given by that. What is the fourth term of this sequence? Note that in this question, they have given us the sum of the first n terms. They have not given us the formula for the nth term. So, but we know that the fourth term can be given by the sum of the first 4 terms minus the sum of the first 3 terms. One, the polynomial Q of x equals that the remainder of 2 is divided by x minus 1. Find the value of b. So this giving a remainder of 2 and when divided by x minus 1 implies that the p of 1 should be equal to 2. We now put it into this polynomial. So p of 1 will be equal to 1 to the power 3, which is 1, plus a into 1 squared is a, plus 2 times 1, which is 2, minus 5, should be equal to this remainder, 2. And from here, a will be equal to 4. A is equal to 4. The key is here. Question 32, we have the sum of r plus 1 from r equals 1 to 100 to be equal to, well, this one can be done in 2 ways. Normally, this will be equal to, if I'm using it directly, when r is equal to 1, you have 2, 3, that's 2 plus 3 plus 4 plus 5, that. So when we look at this, you see that the first term, a, is equal to 2, and the common difference is 1. So applying the formula for the sum of the first n terms, that is from r equals 1 to r equals 100, we'll have 100 divided by 2 into 2a's, that is 4, plus n minus 1. 100 minus 1 is 99 times 1, 99. And when we simplify this, we are going to have 5,150. The key here is D. Equally, you can say this one is the same as the sum of R plus the sum of 1. That is from 1 to 100. Here from 1 to 100. But the sum of 1 from 1 to 100 will just be equal to 100. And the sum of this one will give us 5,050. And for this particular case, R is equal to 1 and A is equal to 1. So that will give us 100 over 2 into 2 plus 99. 99. When you simplify, you are going to have 5,050. Okay, question number 33. Question 33 reads, a point P divides the line segment joining the points 10, 1, and 5, 6 internally in the ratio 2:3. The coordinates of P are. So, as shortcuts for internal division, when the division is A is to B, A is to B, then the X value is given by B Y1 bx1 for the x plus a x2, all this over a plus b. So in this case, our x will be, our b here in this problem is 3. So 3 into x1, that's 3 times 10, plus a is 2, 2 times 5. All this on a plus b is 5. So this gives us 8. That is 40 divided by 5, which is 8. So our x is 8 at the point P. And similarly, the y value is given by the same thing. So b y1 plus a y2, all this on a plus b. And this will equally give us 3 into y1 is 1 plus 2 into 6, all this divided by 5. 2 times 6, 12, plus 3, 15 divided by 5 is equal to 3. So the coordinate of the point P, you have 8, 3. So the key in this question is B. Question 34. The periodic function f is defined on the set of real numbers by that. And you are being told that f of x is the same as f of x plus 5k, where this one just tells us the period of the function is 5. When you equally look at the function from 0 to 3 and 3 to 5, it tells you that the period is 5. So that is just an explanation. So let's look for f of 11. Normally, you know that x ranges from 0 to 5. So any other number should either be a repetition or a copy and pasting. So let us express 11 in the form of this periodic function. 11 will be equal to 2 times 5 plus 1. But since it's a periodic function, this value of f of 11 will just be the same as the value of 1. So what am I saying? So f of 11 will just be the same as f of 1. And this will be equal to, we now take the part of that function in which 1 will lie. So if you look at from 0 to 3, the first function, that's x plus 2, that's where f of 1 should actually lie. We cannot use 2x minus 13 because it will be used if x is from 4 to 5. So f of 1 will be equal to 1 plus 2, which is equal to 3. So our key in this question is D. And the last question for section A, we now move to section B, which is either mechanics or statistics. So, question 35, the value of the constant m for which the graph of the equation that passes through 0, 0 is. So since m is a constant, the value for m for which this function passes through that point. So at the point where x is 0 and y is equal to 0, that's at the origin, you will have 0 to be equal to m into 0 minus 2 squared plus 3. So 0 will be equal to 4m plus 3, implying that m is equal to minus 3 on 4. So B. Thank you guys so much and stay tuned. Don't forget to watch the B part, which is from question 36 to 50 for pure math mechanics and pure maths statistics. Thank you so much, and bye-bye. In question 1,